Welcome to Scale Up University. Welcome to the course on building applications with AI agents. So this is the lecture number 4 of module 1. And in this lecture, we will be discussing foundation models as the backbone of agents. So foundation models, that is like the large language models, they are the backbone of agents. That is what we will discuss. So if we look at the topics that we will cover in this lecture, so we'll discuss what are foundation models, role of foundation models in agent systems, large language models and agent intelligence, natural language understanding capabilities, context retention over long interactions, instruction following behavior, reasoning and task decomposition, generative abilities, text, code, and plans. Model examples mentioned in the course. Why is language a powerful control interface? And finally, we will conclude this lecture by discussing the topic why foundation models alone are not enough. So, all these topics we will cover one by one. So, this is the module 1 Introduction to Agents, lecture 4 Foundation Models as the backbone of agents. And the first topic is what are foundation models? The foundation models are the bedrock or the backbone of modern AI. Now, if I talk about what exactly is the meaning of foundation models, so they are basically a large general purpose model adaptable to many tasks. So foundation models are like a very large model, like a very deep neural network. It is trained on massive, diverse data sets, like massive data sets like petabytes of data and diverse data sets like all the books, web pages, databases, images, audio, video. So diverse data sets. So it's a very foundation model is a very large and it is a general purpose model. And that's a very important thing about foundation models. It means it can solve many tasks. You can accomplish different tasks using the same foundation model. So it's a general purpose model. So foundation model is a very large model which is trained on massive diverse data sets and it is a general purpose model. It can adapt to many tasks. We can accomplish different tasks using the same foundation model. So if we talk about the key characteristics of foundation model, it is trained once, reused everywhere. So the foundation model, we train it once using the massive diverse data and then we can reuse it many a times because we can, it is a general purpose model. And the Gemini, the GPT-4, like the chat GPT, you use, they are foundation models. You use it for so many different tasks. So they have efficient life cycle. Like a single pre-training is needed, and then once the foundation model is trained, we can think about multiple deployments. So the next very important characteristic of foundation model is general purpose intelligence. So it is a very powerful characteristic. Foundation model is a general purpose model. It has got general purpose intelligence because before that, before foundation models, we used machine learning models, deep learning models. They were highly specialized. We can only accomplish a specific task or a specific objective. But here, foundation model, they are general purpose in nature. So they have broad capabilities across diverse domains and tasks, strong transfer learning. So foundation models, they support a very strong transfer learning. So it leverages pre-existing knowledge for rapid adaptation. So this is a very big thing about foundation model. The idea is that like you already did the pre-training of foundation model, you have a foundation model in place. Now you can fine tune it with the new knowledge. That is totally possible with foundation models, and that is what we do. The RAG you use, retrieval augment generation, there you do the same thing. You supply additional context and the response will take into consideration that context. or we can even fine tune the foundation models. So foundation models, they support strong transfer learning. So whatever knowledge they have, we can add new knowledge, we can update their knowledge. That is possible. So that's a very important characteristic of foundation model. And one more very interesting thing about foundation model is the flexible interfaces. We can interact foundation models through natural languages like a chatbot, through APIs, and it can also receive multi-modal inputs wherein you can give it a text, you can give it images also, it can interpret it, it can even interpret videos. So multi-modal inputs it supports. So foundation models, it supports flexible interfaces wherein it can understand natural language, we can interact with it using APIs, and it supports multimodal inputs. So these are like very powerful characteristics, key characteristics of foundation model, like train once, reuse everywhere, general purpose intelligence, strong transfer learning, and flexible interfaces. So if we talk about large language models, so large language models, LLMs, they are the most influential class of foundation models for agents powering conversational and autonomous systems. So the most influential class of foundation model is the large language models. That is what we are using it everywhere. So large language models, they power conversational and autonomous systems. Role of foundation models in agent systems. So in the agent architecture, like if I talk about the agent system, what is the role of foundation model? So we know that agent, like it follows a learning loop, a cycle. That is, perception is the first step. So in an agent, if we look at the agent architecture, so agent will perceive the environment. So there will be a perception engine. So perception engine, what is the role of it? It will understand the input and instructions and context. So perception is all about understanding the inputs, the context, and the instructions. Decision support systems. Okay, before that, reasoning engine. Now every agent will have a goal to accomplish, all that we have discussed in previous lectures. So the idea is that agent, it will perceive the environment, and based on the goal it has to achieve, it will make a plan. It will plan means it will decide the set of actions which needs to be executed to achieve that goal. And for that planning, this reasoning engine will be used. So agents, they have got this reasoning engine breaking down tasks and evaluating options. Then we also have got decision support system in agents, wherein decision support system, it will play a role in evaluating the outcome and ranking actions, choosing the next steps. And we also have communication interface wherein agents can interact with humans and other agents and other tools. So this is like the architecture of agent, wherein any agent you take, it will have a perception engine, reasoning engine, decision support system, and communication interface. Now, interestingly, all these components of agents, they make use of foundation model. They make use of foundation model. And that is the idea. So the idea is that, okay, perception engine is there. It is perceiving some input from the real world. Now, to get more context, we can make use of the foundation model. Like let us suppose we got a image, the agent got a image as input. Now agent can just pass that image to the foundation model, and foundation model will decode that image and give interesting uh, information from that image, and we can use it as context. Reasoning engine is all about planning, that will make a use of the foundation model. So once the proper context is given, the prompt is given to the foundation model, now it will make a plan. Then decision support system will make use of the foundation model to validate the plan and choose next steps. And communication interface also makes use of the foundation model. Let us suppose a agent wants to communicate with a database. So in order to communicate with the database, we have to make use of the query language. So we can make use of the foundation model to get the query. Like it can be a NoSQL, SQL. So we can get the query and we can communicate with the database. It is one example. Like the idea is that if agent wants to communicate with any system, then protocols it has to follow. So a special protocol, and that protocol we can get it from foundation model, wherein we can give a context to the foundation model that okay, this is what we want in a natural language, and it will convert it into a protocol which that system, that API, that interface can understand. That's the idea. So the idea is very clear that agent architecture, all the components, they make use of the foundation model. And if I talk about agent, every agent is goal driven. They have a goal to achieve. They have state, memory is there in place, and guardrails are also there, wherein agent has got a certain level of autonomy, but it cannot do whatever it wants to do. It has constraints, it has foundations, and this execution loop is there, which we already saw: perceive, plan, execute, reflect, adapt, then once again do the same thing. So it's a cycle. So now it's very clear that, and hence foundation model is called as the backbone of agents, because we saw that okay, every component of agent, every module in it is making use of the foundation model. LLMs and agent intelligence. Now see, before uh, large language models, agent was very theoretical. So like agent was just a theoretical concept. Why is it was so? Because before large language model, understanding natural language was very tough. Natural language was brittle because we made some rule based systems to interpret natural language, and that rule based systems were very brittle. They were not at all dynamic. Some ambiguity in the language, it's gone. It will not work at all. The reasoning required hand coded logic. So before large language models, reasoning was purely based on logic which humans used to write, like the rule based systems, the expert systems, the decision support systems. Edge cases, it exploded. So before large language models, any edge case system would not be able to handle it. And maintenance cost was very high. And the biggest bottleneck was understanding and reasoning about open and ended human intent. So this was a very big challenge, because earlier systems before large language models, they wanted a specific input, like whatever we want to accomplish, it has to be very specific. It cannot be open ended. Like I cannot say that I cannot say to a computing system that okay, I'm feeling hungry, I feel like eating something. Then it will get confused. It will start giving you some very weird responses. But large language models, they can handle it. It's an open ended human intent that I want to eat something. Then it will frame very creative cross questions to understand what mood you are to eat: Chinese cuisine, Italian cuisine, Indian cuisine. It will ask cross questions, and then it will guide you in choosing an optimal decision, in making an optimal decision, so that you have a good meal. But before LLMs, this was not there. So now it's very clear that before LLMs, agent design was very challenging, because natural language understanding was very difficult. It was very brittle in nature. Edge cases exploded. Reasoning required hand coded logic. Maintenance cost was high. And biggest bottleneck was understanding and reasoning the open ended human intent. But with large language models, the large language models revolution, so large language models, they act like the cognitive core of modern agents. We already saw in the previous slide also, large language models are the backbone of agents. So this is the large language model, this one. Now it is acting like the cognitive core. So now what has happened is that because of large language model, language understanding has become very easy. robust, very adaptable, very dynamic. So robust language understanding, emergent reasoning abilities. Large language models can reason, they can make strategies, they can make plans. Zero shot and few shot generalization. So zero shot means I am giving a prompt without any context. Like I am giving an input and I am expecting an output. That is zero shot. So the whatever I want to accomplish, that I will get in the first response itself. And few shot means I'll give an input, then some cross questionings will be there, some context I will supply in the subsequent steps, and then after few steps I'll get my answer. So that is few shot generalization. So all that was possible because of large language model and natural language instruction handling. So this large language model, they enabled smooth, intuitive agent design, and that is what we want. So we can see a paradigm shift. LLMs eliminated the biggest bottleneck in agent design, that is understanding and reasoning about open-ended human intent. Large language models can very easily understand and reason open-ended human intent, and it enabled smooth, intuitive agent design. And hence, we are living in the era of agent intelligence. Natural language understanding capabilities. Now, see, natural language now it has become the new universal interface, because now we are communicating with computing systems using natural language. Natural language means the day-to-day language. It can be Hindi, it can be English, it can be Spanish, French, Italian, Chinese. So the idea is to transform natural language into a powerful, flexible interface for human-centric AI environments. So now, like we have models, we call it like the foundation models, which can very easily understand natural language, which can transform natural language into a powerful, flexible interface for human-centric AI environments, wherein humans can interact with AI in natural language. So large language models, they have got advanced linguistic capabilities. And this you might have experienced also, like you have used ChatGPT, Google Gemini, there you have definitely experienced it. So now the large language models, they can understand the human intent driven understanding. They can very easily understand the human intent. Large language models interpret the underlying intent and resolve complex references like this or that. Because if very high ambiguity is there, then also to a very large extent it can resolve that ambiguity. Large language models, large language models, their resilience to imperfect input. So systems can now successfully process ambiguous instructions and messy or incomplete data. So this is something very powerful. So now it's very much clear to us that large language models, they can transform natural language into powerful, flexible interfaces for human-centric AI environments, wherein large language models have got advanced linguistic capabilities. So they support intent-driven understanding and their resilience to imperfect input. And because of that, we have transformational outcomes. And what benefits we can achieve out of it is we can replace rigid workflows. So before, since natural language was not in place, we had to give instructions i- in such a way that computing systems can understand, either in the form of a like flow chart or some sort of programming language. Because earlier computing systems, they can only understand programming languages, so it was like a very rigid workflow. Or if end user is interacting with the computing system, he is interacting either with the click of a button, some kind of graphical user interface by filling some static form and all that. But with natural language, now it has become more expressive, more creative, wherein the interface has become very flexible. So it's a very big revolution we are talking about, wherein the interaction, we used to do it with user interfaces. Now we will be doing it with language interfaces. So flexible natural language replaces the need for static forms and fixed software paths. And this is because of natural language understanding capabilities of large language models. And also like human centric integration. Now the systems, computing systems, they are more human centric, wherein agents they can now communicate naturally and operate effectively with within human environments, and it's very powerful. Like let us suppose a factory is there, or a manufacturing unit is there. Now a new machine is installed. Now very easily, like we can design agents which can help the humans in operating that machine. So the interaction can be in a regional language, in a local language, or any language, and it can be very friendly, human centric. And so the idea is that now we can have human centric computing systems. Earlier, the computing systems, in order to interact with it, some sort of skills were needed. Some sort of skills were needed. But now, even a layman can interact with a human centric computing system, wherein he will talk with it like he is talking to any other human. So that is a very big evolution we are talking about. Context retention over long interactions. So if we talk about core LLM capabilities, large language model capabilities, in terms of context retention, so large language models, they can make use of the historical state utilization. So the idea is that every step the large language model is taking, the output of it is saving in memory. So it is like stateful. It is maintaining the historical state, and it is utilizing the historical state. So LLMs maintain conventional context and recall prior decisions to inform current outputs. So this is the context retention, and this is like very powerful, because context retention, it transforms large language models into autonomous agents capable of multi-step task executions. So now the idea is that an agent has to achieve a goal. Now to achieve that goal, it will make a plan, and that plan will contain many steps, and it will execute those steps one by one. And first step it executed, whatever outcome it got, it will store it somewhere. Now while executing the second step, it will consider the output of previous step. So we are calling it like the context retention. That's a very powerful capability of large language models, context retention. Long interactions it supports because of context retention. Like let us suppose you are interacting with a large language model, and after 1 month you are talking to it. It will remember you if the context is saved. So it makes use of that. Dynamic objective tracking. So models actively track evolving objectives through a complex interaction or workflow. So it might happen that with time, your objective might keep on evolving. Like initially, you started with an intent that, let us suppose you had an intent that you want to visit a place, a nearby place. Then after interaction, your intent, it got evolved. You might now thinking about uh, going for a movie rather than visiting a place, like a random place. Now you are thinking about watching a movie in a multiplex. Then LLM will track it, and then the idea is that the responses it will generate, the strategy it will make for you, the plan it will make for you, it will strictly take into consideration your preferences. That's the idea. Like let us suppose you were willing to visit a mall. Now the idea is that LLM will suggest you a multiplex which is there in that mall itself, so that you can visit that mall also, and you can also accomplish your evolving intent of watching the movie. So that is a dynamic objective tracking, and that is what it supports. Large language models. Contextual continuity. The ability to use historical data to ensure seamless transitions between task steps. That is what is contextual content. So context is something we supply or we pass to the large language model along with the input prompt. The main intent you are giving, that okay, this is what you want to accomplish. Along with that main intent, whatever additional information you are passing, so that is the context. So now the idea is that large language model, uh, it will also take into consideration your input and along with the historical data, which will act like a context for the new output, and it ensure seamless transitions between task steps. Now if we look into why context enables agency, agency means ability to act. Now we know that agents can act. So with context, multi-step task management becomes very easy. Agents require context because goals evolve and tasks span across multiple execution steps. So autonomy versus turn-based resets. So when the context is on, then the system will be autonomous. And why it will be autonomous? Because we started with a goal, a prime intent. Then the agent will always remember your prime goal, the prime objective. Then whatever additional evolving objective you are passing, it is keeping track of that also along with the prime goal you want to achieve. And in this way, it can operate autonomously. It will not need human inputs because it already has stored your intent in the memory. So that's why it can act autonomously. But if state we are not maintaining, if the context is off, then it is turn based, wherein at every step it will be needing human intervention, because every step will be a new step wherein we have to tell what to do, what we want to accomplish. And also influential decision loops. So context, it enables influential decision loops wherein past actions directly influences the future decisions, creating a logical chain of reasoning. So let us suppose agent performed an action and the outcome, it is storing it. Now, while performing the future action, it will also take into consideration the previous outcome, and it will enhance the quality of the agent intelligence. And hence we can see now agents are becoming so smart, they can accomplish such complex task goals. Instruction following behavior. So one of the most transformative capability of LLM is following instructions without retraining. So the idea is that we already saw that foundation models like the large language model, we just have to train it once and it is like a general purpose intelligence, we can make use of it. So it will constantly follow your instructions without needing for retraining. So agents, what they can do is they can keep on receiving goals dynamically. They can keep on receiving goals dynamically. They can adjust behavior without code changes, and they can support diverse workflows. And why is it possible? Because they can follow instructions without retraining. They have what general purpose intelligence. So with evolving goals also, they know how to accomplish those goals. So there is no need for us to change the internal mechanism of foundation model or LLM. So LLMs, they are very adaptive, very dynamic. They can adjust behavior without code changes. No need for us to change the code every time. We just keep on giving it our goals and it will just keep on following the instructions and accomplishing those goals. And this enables agents to accomplish diverse workflows, this general purpose intelligence, and this makes it very powerful. Okay, so earlier the software systems, they were like hard coded, means logic we used to write and they were very specific. They can perform only specific actions. They can solve only specific problems for which the software was designed. Now, if the goal is evolving, like if we are receiving a new goal to be accomplished, then there is a need to change in the code or there is a need to write new logic to solve that problem. So earlier software systems, they were hard-coded behavior. Now agents or the large language models, they are configurable intelligence, wherein there is no need for us to keep on retraining the large language model. Only once we have to train it and we can use it in different ways. A general purpose intelligence, configurable intelligence is already embedded in the large language model. And the good thing is that new knowledge, if you want to supply, you can very easily give it additional context, or you can fine tune it. Reasoning and task decomposition. So large language models, reasoning abilities. Okay, so large language models, we know that it can reason, means it can perform step-by-step thinking. It can decompose complex tasks. So large language models, it can perform step-by-step thinking, decomposition of complex tasks, evaluation of alternatives, and error detection. And for agents, these capabilities, these reasoning capabilities of large language models, it means now agents can break down tasks dynamically using large language models. Agents can plan. Plan can be generated on the fly, and agents can execute. Execution can adapt mid-course. So the core crux is that since large language models has got the reasoning abilities wherein it can do the step-by-step thinking, it can evaluate alternatives, it can break down a complex task, it can decompose it, it can do the error detection. So for agent, the cycle, the learning cycle, we can very easily achieve with the power of large language models reasoning ability. So what agents can do is that they can perceive the environment. Now they will they have to accomplish a goal. So goal is always there with an agent. Now they will make a plan. On the fly, they can generate a plan, which will be like a step by step actions needs to be executed. It will execute those actions. Then it will evaluate the outcomes, and it will detect some error, and it will adapt. Like if there is a need to revise the plan, re-strategize, it will do that. So all that is possible because of the reasoning abilities of the large language model. Because agents, the backbone of agents is the foundation model, the large language model. Now, in every step, agent will be communicating with the large language model. So therefore, we can say that this reasoning ability reduces explicit programming dramatically. Because of this reasoning ability, no need for us to explicitly code, give instructions, or program. Generative abilities, text, code, and plans. Now, large language models, they also have got generative AI capabilities, like they can generate content. Now, large language models, they can generate natural language explanations. They can generate structured outputs. They can generate code snippets. They can generate execution plans. And they can generate tool call arguments. So this generation capabilities, generative abilities, it is very powerful. It enables autonomous agents to write scripts. Now, autonomous agents can make use of the large language model to generate scripts, to generate API calls. Now, to call an API, some specific format is needed, and that format, the structured output, we can get it from large language model. To write script, natural language explanations, we can get it from large language model. To create workflows, the execution plan, we can get it from large language model. To document actions, we can make use of the large language model. So and many more. So autonomous agents, they can perform a diverse set of actions because of the generative abilities of large language models. So generation is not just output, it is operational leverage, because generation is not like the end output, rather generation we can make use midway as an operational leverage, wherein it can support true autonomy. Model examples mentioned in the course. So now it's very interesting that agents, they can also communicate with other agents. We call it like the strategic agent interaction or strategic agent integration, wherein agents they can dynamically swap models. So agents are engineered to switch models based on specific tasks and trade-offs. Like for reasoning, they can make use of a particular model. For context, they can make use of a particular model. For bespoke, they can make use of a particular model. So integration choices focus on reasoning depth, context the scale, and deployment control. And in this course, we will be mainly discussing uh, large language models like the GPT-4. It is used for reasoning and planning. So it is highly optimized for complex reasoning, instruction following, and high level planning support. We make use of Claude for context and safety. So Claude model is specialized in long context handling and built with a safety oriented design. And in this course, we will be making use of Llama for flexibility and control. So this Llama, it provides open weight, flexibility, and significant potential for custom deployment. Because Llama, you might know that it is open source. So open weight flexibility we can very easily fine tune it, and we can use it for custom deployments. So for reasoning and planning, make use of GPT-4. This course will make use of GPT-4 for long context and safety. We will be considering the Claude, and for flexibility and control, we will be making use of Llama for custom deployments. So that is the frame, like the set of models we will be using in this course. So why is language a powerful control interface? So see, if we talk about natural language, so language is very flexible, it is expressive, it is compositional, and it is human native. Like humans can very easily understand the natural language. And these are the core attributes which drive agent interaction. Now, if we use language as a control layer, and that is what in agent architecture, natural language is the control layer. So if I talk about language interface for humans, see, we have an agent. Now to communicate with the agent, we will be making use of a natural language, and agent will in itself be making use of a language to communicate with other agents and to communicate with systems. So humans, agents, and other systems, they will make use of the language interface. Now when agent will be interacting with the humans, it will be more of like natural language, and when agent will be interacting with other agents or with systems, it will be more of like a system language, wherein some protocols will be there, so some systematic things will be there. Now it will basically guide agents naturally coordinate with each other. It will help because if language is the interface, it will guide agents, it will coordinate with, it will help them in coordinating with each other. It describe complex workflows. So at the end, what will happen is like what we will achieve is efficient, scalable, and automation. So language, it replaces legacy systems, because earlier the interaction was like if you want to interact with the system, you have to make use of the configuration files, decision trees, hard coded logic. Now the good thing is that unified language model, it is intuitive and adaptable, and it will take care of the things. Like as a human, you just give your intent in the natural language, and the LLM will generate a specific configuration file for you on behalf of you, and agent can then supply that configuration file to a particular system it wants to interact with. So that's the like a very powerful thing. So we are transitioning to natural interfaces. It's a very big thing. So now designing computing systems has become very easy in that sense. We can be more expressive. We just have to give our intent, and large language model will take care about the specifics, about the protocols, about the configurations, about the system language, about the programming language, about the code. everything can be taken care by the large language model. We just have to be very clear about the objectives we want to achieve, the goals we want to achieve. So modern agents are language centered systems. So agentic framework, agentic AI is all about language centered systems. Okay, now we'll discuss the last topic of this lecture, why foundation models alone are not enough. See, if LLMs alone we take it, they're very passive in nature. Like they're intelligent, no doubt in that, but they're inert, they're passive, they cannot act. So LLMs alone, they cannot act. They can think, they can plan, but they cannot act. And LLMs, like this is an LLM. Now, if we just take LLM, it has no goal. And since it has no goal, no accountability. It cannot perform any action, no action execution. It does not have any persistent memory. It does not have any feedback loop, no feedback. And it does not have any autonomy. Okay, so let us understand it one by one. So large language model on its own, it does not have any goal of its own. Whatever prompt you will give it, it will just give a response for that. It cannot perform any action, like it cannot, and also it does not have any persistent memory, like it is stateless. Okay, you give it an input, it will give an output, it will forget. And it does not have any autonomy. Autonomy means it cannot act on its own. It cannot make plan on its own. You have to tell what you want and it will give you, and the next step you tell what you want, it will give you. So every step you have to give your intent, what you want, and it will give you. So large language model on its own, it does not have got any autonomy. So large language models, if we talk about, they can generate text, they can respond to prompts, but they forget the state unless managed externally. So they are intelligent but inert. But if we talk about agents, agents, they provide agency. Now agents, we know that, okay, this is an agent. So agents, we know that it is goal driven. Every agent will have a goal. It will have a memory wherein it will remember all the interactions. It can make use of the tool. So it can execute actions. Execution control is there with the agent. It can monitor its the outcome of the actions, and it can, human supervision is always there. Human like supervision, human supervision is always there with the agent. So the idea is that, so together foundation models provide intelligence and agents provide agency. So the idea is that agents make use of large language models for intelligence, but agents have got some more additional features, some qualities. They enable agents to act. So agents provide agencies on top of large language models, which provides the intelligence. So the synergy between the agents and the LLMs, this is important. So combining models with frameworks for autonomous actions. And if we combine agents and LLMs together, the synergy, then we can achieve autonomy, autonomous actions. Then agents can like achieve a goal on their own. We just have to tell the agent, okay, this is what I want to achieve. It will do on its own. So that is the agentic mindset. So finally, we completed this lecture. So in this lecture, we saw that foundation models, they made agents practical, scalable, flexible, and human aligned. And it's not about just LLM. The future is agentic systems built on foundation models. So I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.